So now we're going to look at how to do Punnett squares, and we're going to take this off from Mendel's F1 generation, so where he crossed the F1 generations with each other. So both of those F1s were heterozygous individuals. So what I like to do when I make a Punnett square is I like to write the gametes out. All right. Now, principle of segregation states you have two alleles for a trait, but during gametic formation, these are going to segregate or separate from each other so that we have only one allele for a trait in each gamete. So we're either going to have that big T there or that little t there. And same with this individual, either a big T or little t. And so what I'm going to do now is I'm going to make a Punnett square, and a Punnett square is an easy way to figure out what the ratios will be in the offspring. So what you're going to do is you're going to take each gamete and you're going to make either a column out of it, so big T here, little t there. So that's from one individual. And then you're going to take the gametes from the other individual and make rows out of them. So big T there, little t there. And what each box represents is when these two come together. So big T, these two together, big T, little t, these two together, big T, little t, this one, these two together, little t, little t. So what we see here out of this is what we get in Mendel's F2 generation is that we had one big T to two big T, little t, to one little t, little t. All right? And so Mendel's genotypic ratio in his F2 monohybrid cross was a 1 to 2 to 1. Now these guys here, those are all purple. So we had 3 purple to this one right here was white. So his phenotypic ratio in his F2 monohybrid cross was a 3 to 1 ratio. All right? So I'm going to do a couple more here, and I'm going to use this worksheet that you can find on Blackboard. So let's go ahead and erase this. And the first question there says, in a certain species of animal, black fur big B is dominant over brown fur little b. Using the following Punnett square, predicted genotypes and phenotypes of the offspring whose parents are both big B, little b, are of heterozygous black fur. Okay, so heterozygous black fur, they would be big B, little b is crossed with big B, little b. So the gametes out of this is big B and little b, big B and little b. So we're going to make our Punnett square. And so we're going to fill in the box. This box, these two together, big B, big B. This box, these two together, big B, little b. This box, these two together, big B, little b. This box, these two together, little b, little b. Now what it also shows on here is it asks for the percentages. So we need a percentage that is big B, a percentage that is big B, little b, percentage that is little b, and then a percentage that is brown, and a percentage that is black. Okay? So I think I reversed those there. Now it's correct. All right, so our percentage that is big B, well, that's 25%. Our percentage that is little b, big B, little b is 50%, 2 out of 4. And the last one, 1 out of 4, so 25% is little b, little b. Next, black. These 3 here are black, so that's 75%. This one is the only brown one that we have. All right, let's go to the problem on the back side of that. So I'm going to erase all these numbers here. And it says, repeat this process again when one parent is heterozygous black and the other is homozygous brown. So heterozygous black, there would be big B, little b, and this is crossed with homozygous brown. So to be brown, you have to have 2 recessive alleles. So once again, the gametes out of this, big B, little b, little b, little b. So when we make our Punnett square, little b, big B, little b. So big B, little b, big B, little b, little b, little b, little b, little b. Now, just to let you know, doesn't matter what you put on the top and which on the side. So if I do it down here real quick, you can see we get the same answers. All right? So, percentage that is big B, 0. Percentage is big B, little b. Heterozygous is 50%. 50% is little b. 50% black, and then 50% brown. So, that's how you do simple monohybrid crosses.